Hello, my student, and welcome. This is Dr. Sami, and for this question or for this video, I'm going to take you through 8 questions, 8 mathematics questions. And basically, these questions, I've extracted them from a paper 2, that's a mathematics paper 2. So the questions are very appropriate for the Form 4s, ready for the KCSE 2023. Maybe to take you through the questions, I've said I'm taking you through 8 questions. And the first question, as you can see there, you're supposed to solve the equation that you're given. These are trigonometric equation, 1 plus 2 cos of that angle given there, 2 over 3x plus 30 equals to 0. You're given the range from 0 to 360. That is question 1. Question 2, you're given a rectangular block there that has a square base. The side of the square base is exactly 8 centimeters. The height is given to the nearest millimeters. Yes, you can see there, 3.1. So find the percentage error in calculating the volume. Question 3, a binomial expansion question. You can see you're supposed to use the first 4 terms of the binomial part given there, raised to power 8, to evaluate 0.95 raised to power 8, correct to 3 decimal places. Question number 4, you're supposed to make y the subject. Moving on with question number 5. Question number 5. A tap A can fill a bath in 5 minutes. Tap B can do the same, can empty the same bath 10 minutes. Then the 2 taps are opened at the same time. Then after 5 minutes, the tap B is closed. Then how long will it take tap A to fill the bath completely? Then question 6, a matrix question. That is application of matrix. You're supposed to use a matrix method to solve the questions given, the pair of simultaneous equation given. Question number 7, this is a logarithm question. Further logarithm application, as you can read there, my student, then you solve for x. Question number 8, that's a vector question. Yes, you're supposed to find the magnitude of the vector given. Remember, you're given vector A and you're also given vector B. So that is it. So that is the questions. So those are the questions, the 8 questions. So my student, you are supposed to go through the 8 questions yourself before you go through the marking scheme with me. Having stopped the video and then having tried the questions, then we can go through the working. This is question number 1. So my student, when you're given such a question, one thing you should know is that the cos of this angle, 2 over 3x plus that, cannot be separated. You cannot separate this part here. So what you try to do, try as much as possible to remain on the left hand side with cos of that angle. So and that is what the working looks like. So instead of repeating the whole of this angle that I've said you cannot separate, you can let it be theta. And by doing that, I can subtract 1 from both sides. Or rather, what we say, you take this one to the other side. So you subtract, it's the same thing, subtracting 1 on both sides. Then I divide by 2. Yes, I divide this by 2. By doing that, I'll get cos of theta, of which, remember now, my theta represent this part. The cos of theta is -1/2. So what do I need to do? For me to get the angle, I'm supposed to get, or to work out, the cos inverse of 0.5. Remember, that's a half. I've just ignored the negative first because I need to get an acute angle that I can relate with the angles greater than 90, other angles, be it obtuse angles or reflex angles. Now, this is what we call the arc circle, or depending on your teacher and whoever teaches you this one. We do say all the ratios of the angles, that is tangents, cosine, and sine, for angles between 0 and 90 are all positive. For angles from 90 to 300, 180, the sign is positive. Then from 180 to 270, tangents is positive. Then from 270 to 360, cosines are positive. So this is what will guide us, my student. This is what will guide us to do this question. Already we have an acute angle, yes. The next thing we need to ask ourselves, the cosine is negative. Yes, cosine is negative. That means it can be in the second quadrant. How do we get angles, the obtuse angles in the second quadrant? It is 180 subtract the acute angle. Okay, I hope I'm not too fast for you, my student. This one is our cosine was negative. That is something you should bear in mind. If the cosine was negative, it means the angle might have been in the second quadrant, yes, or fourth quadrant. So for that case, then what are you supposed to do? We're supposed to take 180 subtract 60. You get 120. Remember, this is not the value of x. This is the value of theta. So we need to go ahead. We remember that theta was 2 over 3x plus 30. Then we go ahead and we equate that compound angle there to 120. By going through like I've done, yes, you continue until you get your first value of x to be 135 degrees. Then go back to your range. You can see your angle is between 0 and 360. So that angle is, the answer makes sense, my student. That means the answer makes sense. Then you go to the second theta that we can get, actually, yeah, that angle was not in the fourth quadrant, but the third. That is tangent. Only tangent is positive, so that means cos will be negative. I correct that one. I had said it is in the fourth quadrant, but it is in the third. So for the third quadrant, what do you do, my student? You add the acute angle, add 180. Yes, with that 180 add 60, you get 240. 240 there, my student. Now you equate to your theta. Remember, that is your second theta. Equate to this, then go ahead, subtract 30 on both sides. You get 210. 210, then you multiply both sides by 3 over 2. You end up with 315. That is the second value of x. Okay, if you try maybe with another angle, like theta number 3, you say theta number 3 will be 360 plus 120. Yep, if you try with that, try to work it out. The angle and the answer you get will be out of this range. So that means your two answers are 135 and 315. That is question 1. Well done. We go to question number 2. You're given a rectangular block there, has a square base. The side of the base exactly 8 centimeters. So this word exactly, you can see it is in bold there, meaning we are assuming that the sides, the measurement of the sides has 0 error. So we'll be working with the measurement given to the nearest millimeter, and we are assuming the error will be emanating from that. Good. We go ahead and discuss that one. There is the working. The volume of a cuboid, because our block here is more of a cuboid, will be length times width times height. But in this case, the length and the width are the same, the square base. Then L times H. We go ahead and work out the maximum possible volume. It will be 8 times 8 multiplied by 3.15. Where exactly did I get 3.15? The absolute error emanating from the measurement of the height here. Remember, the minimum length I can measure is 0.1. So a half of 0.1 is the absolute error that emanates from this measurement. So in each case, the maximum I will add 0.05. And that's how I got 3.15. 3.15. So the maximum possible volume, you can do the minimum possible volume. Again, what exactly am I doing? To get the minimum possible height, I'm supposed to subtract 0.05 from 3.01. As you can see there, my student, that is the minimum possible volume. The actual volume as they are 8 times 8 times 3.1, and you can see there. So going ahead to work out the error that emanates from the calculation of the volume, I'll take the maximum volume, subtract the minimum possible volume, then divide by 2, and I get 3.2. With that, my student, I'm good to do percentage error. The percentage error will simply be the error itself divided by the actual, or what we call the working volume, then I multiply by 100, and by doing that I get 1.613%. So my student, that is how you go about that one. Question number 3, as you can see, this is a question on binomial expansion, and for this one we are expected to use the first 4 terms. Whatever you're expanding there is 1 minus x raised to power 8, and then we are supposed to use that to evaluate 0.95 raised to power 8. Okay, first of all, my student, you need to know the coefficients. How can you get the coefficients? This one you can just read them directly from your mathematical tables. You can also get them from your calculator. If you check your calculator somewhere on top, you can see a button somewhere written NCR. It's called the combination key. So like if I need this 1, I will press in, because the highest power is 8 here. So it is 8 a combination 0, the first one. I'll get this. Then this will be 8 combination 1. Then this one will be 8 combination 3. Then 8 combination 4, etc, etc. In case you do not have the mathematical table and the third method, you do not have time even to draw the Pascal's triangle. But whatever the case, as you're doing your exams or you're sitting for a paper, you're expected to have your mathematical table, my student. Then having gotten the coefficients, like for now I need the first 4, because the question is well directing. You should use the first 4. So there are the coefficients. With the coefficients, what do I do with them? I write them down, separated like that. You can see 1, you can see 8, you can see 28 and 56. Then what do? I take the first term here, 1 attached to the first term here, raised to the highest power 8. Then the power keep on decreasing. You can see 1 raised to power 7, 1 raised to power 6, 1 raised to power 5. Then the other term here, negative x raised to power 0, that's where you start. Then raised to power 1, raised to power 2, raised to power 3. So what is happening to the second term, or the second part here of the binomial? The power is increasing while the other one is decreasing. So having substituted these values there, and you can see the distribution of marks. So my student, there you earn 1 mark, then it's a matter of reducing it. 1 times 1 times 1. Remember, any number raised to power 0 is 1. Then because of the negative here and an odd number power here, this will be negative. So this one is ordinary mathematics. You reduce that, my student, there. And you can see that one, the negative x times negative x. So the negative will disappear. And that's how this becomes a positive. Or rather, negative times a negative, you get a positive. So by reducing that, you get the expansion, the first 4 terms. So you're supposed to use this expanded term or form here to get the answer to this one, 0.95 raised to power 8. So how do you go about that? We equate what is in bracket here. What is in bracket 1 minus x should be the same, 0.95 there. With that, we are aiming at getting the value of x. So once as you can see what I've done here, my student, 1 minus x is 0.95. Therefore, x will be 0.05. So if I want to solve this one, 0.95 raised to power 8. I'm supposed to take the 0.05 and substitute it where there is x here. Where there is x, I'll just substitute with 0.05. And with a good calculator there, you can see you will work out until you get that one. You get the answer, 0.663. The question was well directing. The student, you're supposed to use or to give your answer to 3 decimal places. Moving on to question number 4, I'm supposed to make y the subject. It's just a matter of doing this rearrangement until y remains on one side of this formula. So my student, you should not fear this. You should go step by step. So which is the first step? To remove this power a quarter here. So if I want to remove a power a quarter, these are fourth root, I will multiply, or I'll raise both sides to power 4. So you can see what I've done. Raise both sides to power 4. Their quarter times 4 will be 1. Then x will be to power 4. That is step number 1. Having done that, now I'm good to cross multiply. Very carefully, I cross multiply 1 times that, as you can see here, my student. Opening the bracket, you can see what has happened. Yes. Okay. And then I have one term here on the right hand side with y, and on the left hand side I also have another one with y. So I put them on one side. Then as you can see here, just it's a matter of rearrangement now. Okay. With that, I can factor out y, because y is here, y is here. So I factor it out. Good. With that, I have a term here that is without x. The way to remove it is to divide both sides by that. 4x to power 4 minus x squared on both sides. So by doing that, I get that. And I can term this as the final answer. However, if I look at this term, the denominator here, it's a difference of 2 squares. So I can say to write it this other format. But I tend to think once you're up to this point, you have the mark. So that is making y the subject. We move on to question number 5. You're given that there's a tap A that can fill a bath in 5 minutes. Tap B can empty the same bath within 10 minutes. Then the taps are opened at the same time. 5 minutes later, tap B is closed. Then how long will it take tap A to fill the bath completely from then? Good. That's how you go about this. Consider this. This is a rate of work. We're talking about a fraction of the bath each tap can fill or empty within 1 minute. So if tap A can fill the whole bath within 5 minutes, it means within 1 minute, a fifth of the bath will be filled up by A. B takes 10 minutes to empty the whole bath. So what does that mean? Within 1 minute, it can empty 1/10. Okay. If that is the case, the remaining amount of water, if these two taps are running at the same time, it is 1/5 subtract 1/10, and you get 1/10. So this is the remaining amount of water within 1 minute. Within 1 minute. So what about 5 minutes? You multiply 5 times 1/10. You get a half. So within 5 minutes, these two taps running together had filled a half of the tank. So what fraction was remaining? A half, the other half. So the other half, remember now tap B is closed. Tap A is filling in the bath at a rate of 1/5 of the tank or the bath per minute. So 1/2 divided by the fractions per minute. By doing that, you get 5/2, which is 2.5 minutes. That is question number 5. Most of the students tend to be confused. You go get finding the LCM. Not necessary. That is how you approach question number 5. Question number 6, a question on matrix, application of matrix. Yes, my student, you're supposed to solve the pair of simultaneous equations that you're given. If you look at these equations, they are not in a way that you're used to. you need to do some rearrangement. You can do rearrangement such that the y's appear first, the x, and then the constants on the left hand side, or the right hand side, that is. So if I do rearrange, as you can see, my students, this is 2y minus 3x equals negative 4, the first equation there. The second one will be 2y minus 5x, this one now on this side, equals to 0. So having done that, I can extract the matrix of the coefficients, the matrix of the variables, and the matrix of the constants, as I have done. Okay, matrix of the coefficients, matrix of the variables, matrix of the constants. And you can see if y was the first, then on top there will be y and x down there, depending on this arrangement here. Then I do the determinant. Okay, the determinant of the matrix of the coefficient, this will be I'll start with this, the principal diagonal, negative 10 minus 6. Yes, and then I get negative 4. Then the inverse of that, it is 1 over determinant. Then, of course, remember what we usually do here. I interchange the elements in the principal diagonal. I interchange. Then the elements in the other diagonal takes different signs. Okay, as you can see. So this is the inverse, as simple as it is. So if I want to solve a pair of simultaneous equations using matrix method, the way to go about it, I had the first order of matrix here. So what I usually do is to pre-multiply with the inverse on both sides. Get what I've said, my student? You're pre-multiplying with the inverses. You know, pre means before, and this one before. And having done that, as you can see, this the arrangement. This is the inverse of the matrix, and this is the inverse. The original part is still there. So, an inverse of a matrix times the matrix itself, you get the identity matrix. So this one I don't need to bother. From here to here, my student, I don't need to bother anything. It will give me the inverse. No, not the inverse, the identity matrix. As you can see, 1, 0, 0, 1. Then multiplied by the yx. On the other side, what have I done? I've taken 5, negative 5 times negative 4. I get 20. 20 minus 0, 3 times 0. That's how I got this 20. Then the other one will be negative 2 times negative 4. I get positive 8. Positive 8 minus 0 to be 8. So you can see that. Okay, on the left hand side, the identity matrix always behaves as 1. So with that, here it is. You can see it will just give me yx. On the other side, open the bracket with negative a quarter. And you can see negative 5 and negative 2. So now I can extract the answers. Y is negative 5, x is negative 2. And that is how you go about that question. The answers, as you can see them there. Question number 7. Question number 7 is a question on further logarithm. You can see what I've done, how the question look like. There's log of 5x minus 10 minus the log of x over 15 equals to the log of 40 minus the log of x over 20, where x can not be equal to 0. With that, I go ahead and try to solve that one. This is subtraction. You're subtracting logarithm. If you're subtracting logarithm, it means the number thereof are being divided. So I can merge these two logarithms, yes, by dividing the first number with the second, like I've done here. The same case on this side. 40, yes, divided by x over 20, like that. Then I can now ignore the logarithm and equate the numbers, just like that. Equate this number with this, because if the log of this is the log of this, it means the two numbers are equal. Okay, simple mathematics. Now do the reciprocal of this, multiply here. The reciprocal of this one, multiply. Try to simplify. Maybe I want to eliminate this x here. I can multiply by x all through. Yes, by doing that, I'll end up with this equation. Having done that, I can take this 150 on the other side. Then I divide by 75. So this one, I've merged quite a number of steps here, my student. So you can try to follow what I've done. Use your calculator to confirm. And the answer thereof will be 12 and 3 over 2. That is further logarithm. Maybe a bit complex because of the fractions and the like, but not difficult to approach. Question number 8. This is a question on vectors. So my student, you're given vector A in terms of the unit vector I, j, k. And vector B is also given I, j, k, you can see. So vector A is 10i plus 6j minus 7k. Vector B is 2i plus 8j plus 4k. You're supposed to find the magnitude, the size of 2a plus a half b. A half b. So how do I go about that, my student? First of all, I can write these vectors in column form. A will be 10, 6, negative 7. B will be 2, 8, 4. Just a matter of writing this one in a vertical form, ignoring the ijk. Then I go ahead. 2a plus a half b. It is 2 multiplied by vector A, as you can see it, plus a half multiplied by the vector B. Okay, opening that bracket very simply, multiplication of vectors with a scalar. You can see, and this one you can see. Then adding them up, 21, 16, negative 12. Simple addition there. The magnitude means, remember now you have the vector a 2a plus a half b. The magnitude means the x displacement in x squared, displacement in a y squared, displacement in z squared. Everything under square root, you get 29 units there. Good. That is the end of the 8 questions, my student. Kindly revisit, maybe replay the video again and again and again. And thank you so much for watching. This is Dr. Sami, and do not forget to come for more. Do not forget to subscribe to this channel. Thank you, and thank you so much.